In the early 1960s, deep in the quiet countryside of New Jersey, a massive horn-shaped antenna stood pointed toward the sky. It belonged to Bell Labs, and its job was simple: detect faint radio signals bouncing through space. Two radio astronomers, Arno Penzias and Robert W. Wilson, were using it to study the universe with extreme precision. But almost immediately, something strange appeared in their data. A faint hiss. Not loud, not dramatic, just a persistent background noise that refused to disappear. They checked the equipment, recalibrated everything, pointed the antenna in different directions, but the hiss was always there, coming equally from every corner of the sky. At first, it seemed like nothing more than a frustrating technical problem. They had no idea they were listening to something far older than any star in the universe. The antenna they were using wasn't ordinary. Known as the Holm-de-Horn antenna, it had been built with an unusual shape designed to eliminate interference from the ground and nearby structures. In theory, it was one of the quietest radio receivers ever constructed, which made the problem even stranger. Every time Arno Penzias and Robert W. Wilson turned it on, the same low, steady noise appeared in their measurements. It didn't matter where they aimed the antenna. The signal remained constant. North, south, day, night. The universe, it seemed, was hissing. At first, they assumed the explanation had to be something local, maybe a malfunction, maybe interference from a nearby city, maybe even radio transmissions leaking into their system. So they began the slow, methodical process. Every scientist knows well, eliminating possibilities, one by one. The first suspect was the equipment itself. Sensitive radio receivers can be incredibly temperamental, and even the smallest calibration error can introduce unwanted noise. So Arno Penzias and Robert W. Wilson began checking everything. Amplifiers, cables, cooling systems. Every component was tested, adjusted, and tested again. Nothing changed. The faint hiss remained. Then they considered something more mundane. Contamination inside the antenna. When they climbed up to inspect the massive structure of the Holm-de-Horn antenna, they discovered two unexpected residence pigeons that had made the warm metal structure their home. The birds had left behind what the scientists politely described in their notes as white dielectric material. In simpler terms, pigeon droppings. It wasn't exactly a glamorous scientific breakthrough, but if that was the source of the interference, removing it should solve the problem. So they cleaned the antenna. Completely. Thoroughly. Then they turned the system back on. The hiss was still there. BT's point, the mystery had become impossible to ignore. The signal wasn't fading, drifting, or fluctuating the way normal interference would. It was stable, perfectly stable. Every measurement showed the same thing. A faint background noise with a temperature of about 3 degrees above absolute zero. For Arno Penzias and Robert W. Wilson, that made no sense. If the noise came from Earth, it should change depending on where the antenna was pointed. If it came from a nearby radio source, it should disappear when the antenna moved away from it. But the signal refused to behave like anything familiar. No matter where they aimed the Holm-de-Horn antenna, the faint hiss remained exactly the same. It seemed to be coming from everywhere, which raised an unsettling possibility. What if the noise wasn't coming from Earth at all, but from the universe itself? At the same time, just a few kilometers away at Princeton University, another group of scientists was working on a very different problem. Led by the physicist Robert H. Dick, the team was searching for something extremely specific: the faint leftover heat from the birth of the universe. According to the theory of the Big Bang, if the universe really began in an unimaginably hot and dense explosion, a tiny trace of that heat should still exist today, spread across the entire sky as a weak background radiation. The problem was, no one had ever detected it. Meanwhile, Arno Penzias and Robert W. Wilson were still trying to get rid of a noise they didn't want. Two teams. Two completely different goals, and neither of them realized they were about to collide with one of the most important discoveries in modern science. Because sometimes, the biggest discoveries in history don't start with someone searching for answers. They start with someone trying to get rid of a problem. And if you enjoy real stories like this, where a tiny, frustrating detail quietly changes our understanding of the universe, this is exactly the kind of mystery we explore here. Eventually, the frustration pushed Arno Penzias and Robert W. Wilson to do something simple but decisive. They started calling other scientists. If the signal wasn't coming from their equipment, and it wasn't coming from Earth, maybe someone else had encountered the same phenomenon before. Maybe this strange hiss had already been documented somewhere in the scientific community. One of those calls reached researchers at Princeton University. When the Princeton team heard the description, a uniform background signal coming from every direction, measuring just a few degrees above absolute zero, something immediately clicked. For years, physicists had predicted that the early universe should have left behind a faint thermal glow, a relic from the moment the cosmos first expanded. And suddenly, it sounded like someone had just accidentally found it. When the message reached Robert H. Dick at Princeton University, the reaction was immediate. Dick and his team had been preparing an experiment to search for a very specific signal of faint background radiation predicted by the theory of the Big Bang. If the universe truly began in a hot, dense state, then a weak thermal glow should still fill space today, cooled over billions of years as the universe expanded. But detecting it was supposed to be extremely difficult. So when they heard the description of the strange noise detected by Arno Penzias and Robert W. Wilson, the implication was almost unbelievable. According to accounts from the time, Dick reportedly turned to his colleagues and said a simple sentence: "Boys, we've been scooped." Someone else had already detected the signal they had been searching for. They didn't realize what it was. Within weeks, the picture finally became clear. The mysterious hiss, detected by Arno Penzias and Robert W. Wilson, wasn't interference, faulty equipment, or contamination inside the antenna. It was something far bigger. The signal matched exactly what physicists expected from the cosmic microwave background: faint glow of microwave radiation filling the universe in every direction. A leftover echo from the moment the cosmos first expanded. For billions of years, this ancient radiation had been traveling silently through space, cooling as the universe grew larger, until it settled into the faint background signal the two astronomers were measuring. What they thought was an annoying technical problem was actually one of the oldest signals in existence, a whisper from the birth of the universe itself. Once the realization set in, the implications were enormous. For decades, scientists had debated two competing ideas about the origin of the universe. One suggested that the cosmos had a beginning of violent expansion known as the Big Bang. The other, called the steady-state theory, proposed that the universe had always existed in roughly the same form. The faint radiation detected by Arno Penzias and Robert W. Wilson suddenly changed that debate. Because the signal matched precisely what physicists predicted should remain from a hot, dense, early universe, the cooled remnant, now known as the cosmic microwave background. In other words, the strange hiss they had spent months trying to eliminate turned out to be one of the strongest pieces of evidence that the universe really did have a beginning. In 1965, the discovery was formally published in two companion papers, one describing the mysterious signal measured by Arno Penzias and Robert W. Wilson, and the other explaining what that signal actually meant. What had started as an annoying background hiss inside the Holmdel-Horn antenna was now recognized as the cosmic microwave background. Faint thermal afterglow of the Big Bang itself, it mantat, in a very real sense. The universe still carries a memory of its birth. Every direction in the sky contains that ancient radiation, traveling across space for nearly 14 billion years before finally reaching Earth, and quietly appearing as a small hiss in a radio receiver. In 1978, the discovery earned Penzias and Wilson the Nobel Prize in Physics. But perhaps the most fascinating part of the story is how it happened. They weren't trying to prove how the universe began. They were just trying to get rid of a noise.